The broadcast is now starting. All attendees are in listen-only mode.
And a pleasant good afternoon, everyone. This is Mike Montefusco from the National Weather Service office here in Wakefield, Virginia. This is our basic Skywarn training presentation for 2024. I'm going to go ahead and wait a minute or so for the top of the hour, but otherwise, this is our Skywarn training class. We'll be getting started in just a moment. All right, good afternoon, everyone. Once again, this is Mike Montefusco here at the National Weather Service office in Wakefield, Virginia. This is our Skywarn training class for 2024. I thank you so much for dialing in and listening to us today. Let's go ahead and talk about our class for the day and it's a little bit of our topics. We'll be talking about the roles of a spotter. We'll be getting into identifying risk for severe weather, as well as how we do that with respect to watches and warnings and advisories. We'll then get into some thunderstorm meteorology with some of the topics you see there, and then getting into some reporting procedures, how to actually give us that information, how to get a hold of us. And lastly, we'll be talking about some spotter safety, how to keep you and your family safe and to remain safe during severe weather in general. Feel free to use the chat feature as we go along. I tend to save questions until the end, but rest assured all those questions will be answered at the end of the class. And for those of you who want to look at the comments, feel free to read the comments below, and we can go through those at the end of the class as well. So let's go ahead and get started and talk about the role of the spotter. And really, National Weather Service spotters are very simply spotters who report information in real time to us here on the National Weather Service. And that information is really crucial in terms of getting that really important information and what's going on in real time where you are. So our spotters really can and do help us keep communities safe during severe weather. Very simply, our spotters help us to keep people safe. So what you see in real time is kind of like what you would see in that picture on the right, which is real conditions, be it a funnel cloud or a thunderstorm or what have you. What you're actually seeing in real time is what you see there on the right. What we're looking at the office here in Wakefield is putting out warning information. So we're seeing what the radar is telling us there on the left. And, well, that image that you see there is what we would call a hook echo, and that would likely tell us that what you see there on the right is in fact happening. But the only way for us to know what's actually going on from a warning perspective is to get that ground truth. So realizing what's actually happening in real time where you are is something that we'll only get from our spotters and get those reports from our spotters. And that report, that real-time verification adds credibility, enhances public response, and improves the warning accuracy. Very simply, if you help us to get those reports, that's going to only increase the veracity of what's actually occurring. So as a look at our radar here in Wakefield, this is actually rotating all of the time, as long as it's an operating status. That dish is always spinning and putting out sound pulses into the atmosphere. And what it's actually doing is it's in surveillance mode. Those sound pulses are actually going out into our thunderstorms and sending out radio pulses or sound pulses. Those pulses bounce off of raindrops and bounce off of everything that can be hit, bugs, pollen, things in the air, smoke. When there's smoke around, it'll basically bounce that signal back to the radar. So what's actually bouncing back to the radar is in that signal is what we would call the reflectivity. The reflectivity is what you're used to seeing on a typical radar presentation, be it on the evening news as you're watching the radar, perhaps if you have a radar on your phone or your laptop. That is what we're typically used to looking at. And the reds and the yellows and the blues and the reds, and the hotter that color is, those yellows, those reds, those oranges, that tells you that there's a really high reflectivity coming back to the radar. So we're getting a lot of that signal reflected back to the radar. So that's going to correlate to heavier rainfall, perhaps some ice or hail production in our thunderstorms. In the wintertime, that could mean, potentially some sleet or some heavy snow or something of that nature, where the signal is actually really getting picked up by our radar. But aside from the reflectivity, we also have the velocity product. And the velocity is actually the radar's ability to determine which direction the air is moving. That's where the D in Doppler comes from in the WSR-88D, which is our Weather Service radar, which was first commissioned in 1988. And the D in Doppler is what we usually hear about. Doppler, Doppler 10, Doppler 12, Doppler 19, Doppler whatever. That basically comes down to the radar's ability to determine which way the air is moving, which direction the air is moving in. However, there are some significant limitations to that radar. With respect to the radar beam itself, because of the curvature of the Earth, the radar beam is going to be seeing higher and higher up the farther and farther it goes away from the radar site. So from our site here in Wakefield, we can see storms that are really close to the radar. We can see a lot of the low-level detail of those thunderstorms. So middle and lower portions of that storm, we can see a lot of information, get a lot of information about those storms. But as you get to the outer edges of that range, say 150 miles or greater, certainly, you're going to start to pick up less and less information from those thunderstorms. And a lot of the details will start to get kind of fuzzy, and the resolution will start to struggle and start to suffer as you get farther away from the radar. So the resolution suffers as you get farther and farther away from the radar. And that comes from our spotters. Our spotters help us to supplement that data. And we have other radars that we can tap into as well, but the spotters help us to save lives. Our spotters help us to save lives. And we thank you very much for being part of that process to actually help us keep people safe during times of severe weather. Taking a look at some climatology information, and this is severe weather probabilities as you go through the year. And as you get into the darker colors, you get into higher and higher probabilities. And you'll notice right about now, you're getting into the April and May time frame where we start to get higher and higher probabilities across the Ohio Valley and the Carolinas and into our area here in the Mid-Atlantic. And then by middle July, it starts to suffer a little bit, starts to drop off, the probabilities do. And that tends to match when we get into more what we call hydro season here, where the storms become less about severe weather and more about just dumping lots of rain. And that tends to be our severe weather mode, where we get into a lot of the spring months. We get into hail, certainly in the first part of the year when there's some cooler air aloft. But as you get into the middle and later spring, it gets to be more of a gusty wind threat and heavy rain threat. And then into the later spring and summer months, it gets to be more of a heavy rain and lightning threat. By and large, there are obviously going to be exceptions to that rule when strong storms threaten and the like, but certainly that tends to be how it goes on average. And then as you get into the later summer, we get into a secondary peak of severe weather potential with respect to tropical weather. And then as tropical storms start to develop and move towards the contiguous United States, we start to have more chances for heavy rain and gusty winds as well, moving into our area with decaying tropical systems. Taking a look at the climatology for our area, this was compiled by one of our forecasters here. You can see that there is a couple of really honed in areas for tornado warning density, and you tend to see a bit of an urban influence here with respect to Hampton Roads, with respect to the Richmond metro area, and certainly up even into the northern neck and the eastern shore of Maryland, where we start to have a little bit more of a social science standpoint, if you will, where we have greater concentration of warnings, where we have greater population concentrations. And that tends to come from where we get spotter reports from, is where we have more spotters that are actually reporting that information. Similarly, if you're looking at thunderstorm density, the metro regions, once again, are kind of hot spots because we do get a majority of our reports from those urban areas, more urbanized areas where most of our spotters are living. And again, that doesn't say that the more rural locations don't get severe weather. Of course they do, but again, fewer and fewer reports from those less populated communities tend to result in fewer reports, and that is what you can see on this map here. And we take off the spotter reports themselves, and you can see again where we kind of hone in on the urbanized areas, so to speak, even in the Hampton Roads area here in Wakefield, back into the Richmond metro and northern neck. That same signal tends to apply. And then certainly for flooding, once again, the urban centers, kind of hot spots, so to speak, with respect to flooding. And that makes sense, right? Because water and more concrete tend to not mix very well together. And certainly when you have heavy rain over a prolonged time in more urbanized areas, bad things tend to happen with respect to flooding and flash flooding that occurs in those areas especially. So next we'll get into identifying the risk, and this is a general preparedness paradigm that we use here at the National Weather Service with respect to days ahead of time getting into the outlook portion of things. We'll talk about severe weather potential through our social media channels, through the hazardous weather outlooks that we do. We'll talk about those in just a moment, and through our forecast in general. And we tend to use this as a get ready portion. From get ready, get set, go. This is the get ready portion. The day of a severe weather event, we'll start talking about getting set, and we do that through monitoring the weather and looking at the latest weather forecasts is what we tell our users to do. And certainly we say, certainly check our forecast, keep abreast of the latest information through thunderstorm watches, tornado watches, flood watches. That's a very important part of the process, and we'll talk about the watch versus warning portion in just a moment. The go portion is the advisory or the warning, and that's where you would generally take shelter. That's where the rubber meets the road, so to speak. That's when the weather is either about to happen or is happening. So that's when the warning phase comes into play. And certainly seconds matter in situations like that. So again, we tell folks to monitor the latest information and be ready to move if need be. In terms of the different probabilities and the words that the Storm Prediction Center uses in their outlooks, you'll start hearing terms like marginal and slight and enhanced and moderate and high. And very simply, the weather itself doesn't care about what the category is. This is really just a paradigm that we try to explain to our users how widespread we expect the storms to be. How long in duration do we expect them to be? And very simply, the higher on the scale this goes from 1 to 5, the more concerned we are for how widespread and severe the storms are going to be. So in terms of planning the timeline out for a storm prediction, a few days out is, again, make sure you have your supplies on hand. Have an emergency plan that you start to work through with your friends and family. Figure out safe places where you're going to be, where you're going to kind of hang out as the storms move through. The day before, adjust those plans. Make sure you have enough information and enough places to get warning information that you have the information that you need. Make sure your phones can receive WEA, wireless emergency alerts. Make sure your shelters are clean and accessible. Make sure there's not, a lot of junk or, stuff that will keep you from taking shelter effectively. The day of the event, again, run through your communication plan, know how to evacuate or get to where you need to be safely. And when a warning is issued, you may only have seconds, so be ready for that. Have as many different ways of getting warning information as possible, be it through the weather radio, as a NOAA weather radio, or through our website, or through your favorite weather application, whatever that might be. Use that and make sure you have that information. Taking a look at our website at weather.gov/Wakefield, this is the way to keep abreast of the latest information for your safety and spotting purposes, and also for your awareness. So if you look at this page, NOAA weather radio information is there. So the latest forecasts and the latest frequencies for NOAA weather radio are available for your use there. If you don't have a NOAA weather radio, we strongly recommend those because that will have the latest forecast information that will be sent to you within 15 to 20 seconds at most when a warning is issued. The Skywarn page is a great resource for the latest information in terms of the latest classes, how to report, and all of our handouts that we will give in the future and presently are all housed at that webpage. The briefings page has the latest weather information. So you'd be able to brief yourself with the latest forecast information that's available. You'd be able to look at the latest conditions, the latest forecast analysis, the latest products from our colleagues at the Storm Prediction Center out in Oklahoma. You'd be able to brief yourself with the latest information on that page, and it's all in a one-stop shop. If you go to our website at weather.gov, you'll also notice a weather story. That's something that's reasonably new at our webpage, and that is a graphical forecast of what we're discussing, what's the biggest weather story of the day that we're keeping an eye on. You'll see graphic information there. So you might see an overview of the severe weather potential or the rainfall amounts that are expected through a particular time frame, and we'll give you just the latest information of what we're expecting. And these will be shared on our social media feeds as well. Just taking a look at some legacy type text products that are also available on that same page. The area forecast discussion, this is a really great product that I hope that everyone is using to kind of get a glimpse into how we're making the forecast every day. This is a bit more of a technical product now, so there will be a bit more information here than you might be aware of, but we are going to put the technical details in the forecast. So what went into our forecast, what we're thinking, what we're expecting, any timing changes or probabilistic information. We're going to really start to get into more statistical number crunching in terms of what the most likely scenario is, what the potential worst case scenario is, the most likely scenario that exists there. So we're going to be discussing that in the forecast discussion. We'll also be getting into, within the forecast discussion, times and forecast confidence as well, which is also very important. Next, we have the hazardous weather outlook. And for those who don't really want that nuts and bolts forecast information, this is your go-to. This is going to be the hazardous weather outlook that's going to very, very simply talk about what we're expecting and when we're expecting it. So this is updated once a day at the very minimum, typically more than that on a daily basis, 2 to 3 times a day. And it will have, again, the most detailed information broke down into very small digestible bites, so to speak. Now, the spotter information statement on the bottom here, please don't feel that you need permission from this to report to us. If it says spotter information is requested, by all means call. But if you have something to report, by all means, give us a call and give us the information that you have. Now, this is a new product. This is called the Graphical HWO. This is available on our website at the URL you see there. And this is broken down by geographic area. So you can kind of see kind of broken down by individual hazard, from severe thunderstorms, tornado, wind damage, hail damage, lightning, all the way down. You can kind of see portions of the area are outlooked for those particular hazards, and we break them down one by one as you go through the calendar. So you can kind of see which areas are outlined for what threat, and it's a very good graphical representation of what it is that we're expecting. And that's available on our website at all times, once again. Now, looking at watches, warnings, and advisories. Very simply, if you look at our thunderstorm definition, we have definitive criteria with which we're seeking for thunderstorms that move through the area that we issue thunderstorm warnings for. Those being 1-inch hail, which is basically the size of a quarter in diameter or larger, and or 58-mile-per-hour wind gusts. Now, those are gusts that are, to 58 miles per hour, 60 knots, or 55 knots there, that you'd be able to see across the area. And then we have lightning there. You notice that we have a little bar that goes through that, and that basically tells you we don't issue warnings for lightning. By definition, we'd be issuing warnings for every thunderstorm that moves through the area if we were to issue for lightning. And that's not something that we do, and that's obviously not productive for anybody. So lightning is not going to be a basis for our warnings, but hail and wind gusts are our basis. Now, how do we communicate those? Our social media feed is a great way to figure out what's actually going on in real time with our products, and specifically our Twitter or X feed, however you like to call it. This is when conditions are favorable for hazardous weather in and near the watch area. So we have our tornado watch that you see there, and that's typically for a larger area. Could be for portions of some states or multiple states, and it's going to be for longer periods of time. And these graphics will tend to break down what we're expecting and when we're expecting it. And these are issued through the Storm Prediction Center out in Oklahoma. And they will communicate with us, and we will collaborate with them and issue these watches for generally 4 to 6 hours at a time when conditions are favorable for a particular hazard to occur in and near the watch area. Now, with respect to the warning, these are warnings that are issued for when we expect weather to be either occurring at that time or are imminent or about to occur. So those warning polygons are going to be for a smaller area because of that, and basically reflect the area that is under greatest threat. We do have the ability to issue what's called a tornado emergency. In exceedingly rare instances, basically when we have evidence that there is a tornado on the ground doing damage, we can issue what's called a tornado emergency. And that is for tornado on the ground doing damage. Very simply, if you have a watch, we're looking at the ingredients to come together. So if you're making tacos, we're putting all of those ingredients for tacos together. So if you prefer cookies, we're putting all the ingredients for cookies together. Whatever you're looking for, we're looking for those ingredients to come together. And when we have our finished product, that's when our warning goes out. So when, in the case of tacos, we're having tacos when all of the ingredients have come together and we have something ready to go. And we're going to do that right now. So that's what the warning is. We have everything that's come together, and we're basically at showtime, so to speak. Now, for storms that are not quite to severe levels, we have storms that are notable, but not quite by the book severe. We have what's called special weather statements to handle those. So for storms that are strong, say producing 40-mile-per-hour wind and small hail, we will issue what are called special weather statements. And these will go out through our social media feed via Twitter or X as well. And we will call attention to whatever hazard is going on, be frequent lightning or gusty winds or small hail or whatever's going on there. And again, that'll communicate the threat without actually saying there's a warning in effect. This is a good time to talk about the warnings themselves and talking about how you receive warnings. They're having multiple ways of warning is the or receiving that information is the ideal. So basically have as many different ways to get that information as possible. So if one of them were to fail, you would still get the information. So WEA, those are wireless emergency alerts that come directly to our phones. We have TV or radio, our internet or mobile applications on our phones. NOAA Weather Radio, your favorite weather app, whatever it might be, the warning system in your county, or the NWS mobile widget, which is at mobile.weather.gov. All of these tools are great and available to provide you with warning information. A note about the wireless emergency alerts: these are sent through authorized government agencies to give you that weather information, and it's only going to be extreme weather warnings, local emergencies like considerable severe or tornado warnings that go out, amber alerts, presidential alerts, or what have you. Those are going to go directly to your phone at no cost to you. So let's get into some thunderstorm meteorology here. So let's talk about some severe weather ingredients and thunderstorm formation. And on a day where we start to have the sun out and we really start to light and heat the earth up, basically the air starts to become lighter and rise. This is known as increasing the instability. So the sun lights and heats the earth, and in turn, that ground will warm the air around us. So not unlike heating water on a stove or putting heat into a hot air balloon, basically we're indirectly warming the air around us and creating increased amounts of instability. In the presence of enough moisture, the lift will increase cloud cover, will basically produce lift within our cloud cover and start to elongate our clouds or stretch the clouds in the vertical direction. And this is going to create an updraft, which can turn into what we call a towering cumulus cloud, which is just literally a towering cloud that's going up and farther up into the sky. So we have moisture, we have instability. Our third ingredient is lift. The lift is basically an agent that kickstarts that updraft thunderstorm development process. So that could be a sea breeze, that could be a front of some kind, basically something that's going to produce that increased updraft and thunderstorm development. So some agent that's going to kick that change off. So our mature thunderstorm is going to have a fully developed updraft and downdraft, and that symbiotic relationship between those two is going to keep our thunderstorms active. So our updraft is in the yellow, and that's going up into our cloud. And you can start to see the sky behind that is in a kind of a clear, more of a clearer mode. You can see more of it. That is more what we call a rain-free base. So we can see there's not much rain there. It's just air going up into our thunderstorm. Versus the downdraft, and then you can see there's less of a clear sky back there because that's where our heavy rain and outflow is coming from our thunderstorm. So aside from our updraft and our downdraft, the other ingredient we need is wind shear. For our thunderstorm to survive, we need something to keep the updraft and downdraft separated from each other. If they're on top of each other, they're basically going to cancel each other out and keep our storm from developing. So basically there's wind shear in one of two different ways. We have speed shear, which is an increase in wind as you go up with height. And secondly, we have directional wind shear, which is changing directions with height, typically from southeast at the surface to west-northwest at the top of the thunderstorm. Both of these phenomena will end up producing a storm that is rotating and kind of tilting a little bit. And that tilt is going to allow our storm to keep the updraft and the downdraft separated from each other. So here's kind of an example of directional shear. Here's an example of speed shear there on the left. And again, in both cases, the net result is going to be a thunderstorm that is able to keep the updraft and the downdraft separated from each other, and therefore keep the storm from weakening too strongly. That's kind of another look at it there. You can see the downdraft portion down in the blue, the updraft portion there in the yellow, and then the updraft is going to be directly underneath that updraft. So you can start to see the air lifting up into our thunderstorm. And again, that wind aloft is going to allow this to keep the updraft and downdraft separated from each other. Now, if we don't have that, what happens? Well, if the updraft and the downdraft are kind of co-located, we tend to have a storm that will cancel itself out, and the storm will just collapse on itself and die. So best way to kind of picture that is kind of think of a very humid, still, late summer afternoon where it's really humid. Thunderstorm might pop up. It'll rain for 5 to 10 minutes, and then it'll just rain itself out and die off. And that is a good example of not having much shear, because typically in those in those summer months, you're not going to have much shear to play around with. So typically those storms will go up. There's not going to be much shear, and the storm will just collapse on itself and die out. So you look at our thunderstorms, the single cell are short-lived. They might have hail and gusty winds, typically not going to be severe. These are your more garden variety type thunderstorms, so to speak. Your multi-cell clusters are storms in different stages of development. They may merge together, but their speed are occasionally going to produce large hail and damaging winds. The squall line is the most frequent portion of severe weather, can extend for hundreds of miles, can persist for quite a few hours, and produce damaging winds and hail. This is our most frequent type of severe weather. And the supercell are powerful storms producing the majority of severe weather in the United States. They produce extreme winds, flash flooding, and large hailstones. Typically, when you see a supercell, they're almost always going to bring severe weather to the party in some form or fashion to some place as they develop. It's not going to be for everyone in a lot of cases, but you're going to get thunderstorms that develop and produce severe weather somewhere. This is a good example of the squall line, and you can watch the movement here of the squall line. And you can see this is the majority of our severe weather cases. This is a particularly good case here, where you just get a long line of storms that move through. And this is typically on the leading edge of a frontal passage, like a cold front, for example. You might see this come through. You might have a really warm air mass with a cold air mass coming back from the west, coming across it. And as you can see the timestamp there, this is a ways back, but it's a really good example. The early spring months are notorious for things like this, where you have some cooler air mass kind of advancing on an unseasonably warm air mass, and that tends to produce a big area of showers and thunderstorms that move through. So with the squall line, the primary threat is going to be damaging wind. You're almost always going to have what's called a shelf cloud that's going to be present there. And the shelter cloud is really nothing more than the leading edge of the cooler air coming in behind. And you'll notice that you'll see kind of a clearer sky underneath. That's going to be generally all of the gusty wind is going to come from underneath our thunderstorm, right underneath that shelf cloud. It's going to come right out of your screen there. So as you're watching this, the gusty winds are going to come from underneath that shelf cloud right out at you. So watching that shelf cloud come through, if you're in this location just ahead of the gust front there, so let me do that there. So as you're in this location just ahead of the gust front, all of this warm air is going in as inflow into our thunderstorm. So all of this warm air is feeding into our thunderstorm as inflow. So you might have a nice warm southerly or southwesterly wind out ahead of our storms. And then as the storm comes upon you, what do you think of when you think of a thunderstorm coming into town? Is that burst of cooler air. That's that rain-cooled air coming out of our thunderstorm and kind of announcing the thunderstorm's arrival. And that's that gust front coming through and pushing into the area. So all of this outflow coming out of our thunderstorm is going to hit the ground and then diffuse out. And that's going to be the leading edge of that is going to be our gust front. So with our shelf cloud, the worst is going to be first with respect to severe weather. You're going to get the heavy rain, the gusty wind, potentially some hail. You're going to get that first as the storm first comes into town. As that storm starts to move on out, the rain's going to diminish, the hail's going to diminish, the winds will calm down, and the storm will finally move on its way. So again, with the shelf cloud, the worst is going to be first. So watch the center building here, and you can kind of see the squall line queue up. So here comes all that dust and all that outflow, and there it is. So at the beginning of the video, there wasn't much wind. As we get to the end of the video and the gust front is coming through, we get that outflow from our thunderstorm producing that wind, and that's when we start to get that wind started. So next we'll talk about supercells. And supercells are almost always, again, going to produce severe weather in some form or fashion. And this was a storm in 2017 that produced some quarter size and larger hail in the Richmond metro area. And what makes supercells so dangerous is because of the plentiful shear that it has available to it in terms of shear and instability. We have basically storms that are rotating even in the inflow stage. When we're bringing in air into our thunderstorm, it's going to be rotating even before it's severe, which is going to add an extra element of danger to the whole scenario. Now you'll notice the overshooting top here. The overshooting top happens when we have a particular amount of strong lift going into our thunderstorm. And when we have a bunch of lift going into our thunderstorm, we tend to get to the top of our thunderstorm and then bust through the top of that thunderstorm. So basically the top of our thunderstorm just gets pierced by the updraft wind coming through our storm. And that's going to produce a little hat on top of our thunderstorms. This is what they look like in real life. You'll see these little overshooting tops. When you see that, that's your clue that there is some stronger wind going upwards in the vertical, and what goes up must come down. So when air goes up into our thunderstorm, that's telling you that you have the potential for some strong wind and some large hail with that overshooting top. Now, in terms of the hail, the bigger the updraft, the bigger the hail. We look at that little dotted white line there, we'll call that the freezing level. And as we get enough moisture lifted above that freezing level, the more moisture we get up above that, the more we can get ice, some ice particles start to develop and kind of bounce around in that sub-freezing layer. And the more those ice nuclei bounce around in our cloud, kind of think of the little ping pong ball, lotto ball machines that from the old days, where you basically have ping pong balls kind of bouncing off of each other and accreting moisture, picking up moisture. And the more time they spend bouncing around in that cloud, picking up moisture and being held up by the updraft, the more time that they have to get large and pick up more moisture and just accrete moisture and pick up and get bigger and bigger and bigger, to the point where if the storm can no longer handle the weight of those hailstones, it will just drop those hailstones on whatever town it happens to be over at that point. So the stronger the updraft, the more weight it can handle in terms of ice within that thunderstorm. Now, the dangers of hail, pretty clear in terms of the damage that it can present to vehicles, crops, structures. Obviously, it can also produce hazardous driving conditions as well. So it can produce all of that and more. So again, very large hail can produce from updrafts. This is our updraft champion still, the Vivian, South Dakota hail from 2010, 8 inches in diameter, 18, a little more than 18 and a half inches circumference, and just under 2 pounds. No loss of life with this, thank goodness. Just a bunch of crop damage that resulted from these hailstones. These are just some of the dangers that hail can present over the years. So let's switch over to damaging wind and look at the damage that can present. And you look at straight line wind, and for some reason, folks just tend to take this as a slight when they hear straight line wind damage as opposed to tornado damage. And there's really no, disrespect intended in terms of that. It's just basically referring to wind that is not directly associated with tornadic circulation. So it's not from a tornado. It's just outflow from a thunderstorm. It could be from a downburst, which is just wind coming out of our thunderstorm, or a squall line gust or a gust front coming out of our thunderstorm. Now, in terms of the microburst itself, we have certainly areas of strong winds that can produce from an outdraft, from a downdraft. So if I were to take a water bottle, picture of me just pouring a water bottle on a table, and if water is going to make contact on the table, it's going to hit that table and diffuse outward. So that area that's first impacted, is that going to have the worst damage? Yeah, it's going to. The worst damage is going to be in that very small area within 2, 3, 4, 5 miles of that initial microburst or downburst coming down to the ground. And that's going to be a very small area. But is there going to be additional damage outside of that? Sure, because that water doesn't stay in one spot, right? If we pour water onto a table or liquid onto a table, it's going to diffuse outward. It's going to spread outward, and it's going to make a big mess. And the wind is going to do the same thing. It's going to behave like a fluid. And as a result of that, we're going to have additional damage. So we can have wind speeds of 50 to 100 miles per hour that emanate outward from this initial point of damage from the microburst. So additional damage is likely. So watch this video here, and hopefully that gets the point. That gets the point across effectively. There it is, right there. So with that initial point of damage, certainly the worst damage is in the middle of your screen there, but you go farther out, and certainly there's additional damage that was felt from this thunderstorm moving through. So the precipitation core, crashes to the ground and produces damage in the middle of that screen there, but the additional damage is, pretty clear from what goes outward from that initial point. Now you look at the damaged field itself, it's going to be fairly similar when you have a squall line move through. You're going to produce damage similar to knocking dominoes over on a table. Or if you knock a bunch of things over in succession onto a table, you're just going to kind of knock things down in succession, real flat damage path. You can see this kind of moving through very, very uniformly, very, very similarly, where you have damage that's very, very uniform. It's kind of, we call this a kind of a divergent wind path, in that it's all just kind of spread through a single field. A tornado is going to be, by contrast, convergent. So all of these lines would start to converge to a single point. So all of these lines, picture them kind of coming together at a single point. That's going to be your convergent damage path versus the divergent damage path from a downburst. So the squall line winds are going to move quickly, can produce damaging winds over a large area, and if they move too far ahead, you can start to see the storm start to weaken. So you start to see this little blue line start to move out ahead, sneak out ahead of our thunderstorms. That tends to tell you that you're looking at your gust front moving faster than the storms are. And then at that point, the storms are going to weaken because they don't really have as much forcing it or pushing it through as you would have in a more severe situation. All right. So as far as the bow echo goes, the bow echo is an area of enhanced wind and more significant damage. So typically, as you're watching damage come through, have a couple questions coming in. I'll get them at the end, I promise. You start to look at, let me grab my highlighter real quick. You can start to see kind of like you're putting in a bow echo, kind of looking at like bending a bow back, like a bow and arrow. At the apex of this bow, at the very front, that's where the greatest threat is presented in this case. All of your wind is going to kind of queue up right here at the apex of this bow. And you can kind of see these storms are headed off to the northeast here. So your worst weather in this case is going to be at the apex of this bow, where the brightest reds are. You can kind of see here. Again, this is the velocity data here on the right. So the really bright reds, this is going to be going away from the radar. So these bright reds are telling you your strongest wind moving away from the radar. Which brings us to the derecho. And folks will tend to use derecho and strong windstorm interchangeably. There is a bit of a spatial component to the derecho in that we're looking for a damage swath of greater than 240 miles or greater. And that's going to be typically going to be an unusually warm and moist air mass that is going to find these. The derecho of 2012, for those who don't recall, that was a very, very hot day here in the local area here in the Mid-Atlantic. So we had temperatures well into the 90s to low 100s. Heat advisories were in effect. It was just a really hot day. So you need that kind of really hot, sticky air mass to produce derechos that produce that much damage over a large area. And widespread wind damage comes from a derecho. Otherwise, it's just a strong wind event, which certainly is nothing to sneeze at in most situations. But for it to be called a derecho, it does need to cover greater than or equal to 240 miles in coverage. Now, in terms of flash flooding, really these can produce some really significant damage as well. Rapid rise of water onto previously dry area, impacting roads, impacting travel, could go into homes and businesses. Can also be a result of dam breaks, for example. But again, these will be the most severe flooding. And the force of flash flooding can move cars or even houses, particularly houses when they're not fastened to a foundation, can be moved fairly easily by floodwaters. That's why we say turn around, don't drown. Don't put yourself into situations where the water will determine where you're going, because then at that point, your amount of control of the situation goes down considerably, and the water's taking you where it wants to at that point, and we certainly don't want that. Now, in rare cases, we do have the ability to issue what's called a flash flood emergency. This would be, again, in situations where there's an extremely high risk to life and property, and similar example to that would be over 9 inches of rain in 2 hours in the Ellicott City area here outside of Baltimore, which produced flooding like you see here. So very significant and dangerous situation. So certainly cases like that, we can issue a flash flood emergency, and that is something that we have the power to do. Hopefully we don't have to, but if something like this is to arise, it would likely be something like you'd see here. Again, the watches versus the warnings is a very similar situation. The watch is when we're watching for ingredients coming together for flooding. The warning is when that flooding is already happening or is about to occur. And we say flooding will occur and flood out roads. We say move to higher ground and don't drive through flooded roadways. Again, turn around, don't drown is something you're always going to hear us say because we don't want you to be stranded in that flood water. For less severe cases, urban small stream flooding, flood advisories or something of that nature will go out on our social media. Standing water on roads, the more typical flooding of overpasses, underpasses, flood-thrown roadways, things of that nature. Things that are not really life-threatening per se, but can nonetheless snarl traffic or cause travel problems. We're going to put those out for something like that. You'll get a graphic for this as well on our social media feed through Twitter or X, and you'll get kind of a quick summary of what's actually occurring. Basic steps, very simply, get to higher ground, don't drive into floodwaters, and stay informed as much as you possibly can as to what's going on weather-wise. Now, this is normally where we would take a 10-minute break, but since we're on a online format here, we're just going to plow on ahead here and get into part 2. Feel free to take a break wherever you are, and we'll go on into part 2. Talk about the enhanced Fujita scale. We'll talk about tornadoes. And again, the Fujita scale, very similar in that we're going to go upwards with intensity. So as we go from 0, 1 through 5, we're going to get into increasing levels of tornado damage. So from 0 to 1 to 2 and 3, we get into more and more severe tornado damage. And this was something that was actually reimagined back in the mid 2000s. Some of our scientists went back with research meteorologists and physicists and some insurance meteorologists and kind of got into what kind of damage occurs at certain speeds, certain wind intensities. So what kind of damage is necessary to produce the damage that we're seeing? And from that, we gathered what are called damage indicators. So when our storm survey teams go out from the National Weather Service, we will go out and we'll look for specific types of damage that'll be indicative of certain wind speeds and certain intensities for tornadoes. And we're going to use that. There are hundreds upon hundreds of those intensities that are within our storm survey kit that we use to kind of quantify what it is we're expecting. Now, as we talked about the shelf cloud being part of our thunderstorm with respect to straight line wind, the wall cloud is going to be something that we are using and watching for with respect to tornadoes. The wall cloud is an isolated lowering of the cloud base, usually at the base of the updraft. And what happens is the updraft is ingesting that rain-cooled air, which is a good reason that it is typically going to be pointing towards the rainfall area. You look at the wall cloud here; it's going to be pointed towards the rain-free base area, or excuse me, toward the rain area. So you're going to start to see the darker sky back here. You see the rain-free base behind it. It's going to be pointed towards the rainfall area. Now you'll see that this is going to be rotating, which is going to imply a rotating updraft. And that updraft is typically your clue to watch for a tornado. So as we watch this wall cloud, you're going to watch the wall cloud in the center of the screen. You're going to watch the inflow, that's the wind coming in from the right side. You're going to watch the outflow coming around on the left side. That's the storm breathing out, so to speak, pushing air out. And you're going to watch the rotation itself. Now, this feature is going to be kind of accelerated for time just to show the effect, but it's going to be very, very similar in every tornado that you see. You're going to notice very, very similar things at play. The tornado is going to drop out of the bottom here underneath. And the updraft goes up over the top. The anvil would stretch out up and to the right. So you'll start to see the anvil here in the upper right. So let's put this thing in motion. And again, this is accelerated for effect, but again, you can see everything at play here. And then the tornado is going to come from underneath and start to make its way toward the ground. And that's why we tell people to get as low as you possibly can, because the tornado is going to descend from the wall cloud, and you want to get as low as you possibly can to be as safe as you possibly can from this tornado. So the key to spotting our wall cloud in this picture that you see there is going to evolve as we go forward. You're going to see sustained upward motion. Is the feature persistent? Is it attached to the storm base? It wasn't when we started the video. It now is. So you can start to see it's hooking up with the bottom of the bottom of the funnel there. So it's starting to hook up with the wall cloud and the storm base. Next, we're looking for a vertical axis of rotation. In the previous portion of the video presentation, we were talking about the horizontal axis with respect to the shelf cloud, just a spinning column of air in the horizontal. In this portion, that's not what we're looking for. We're looking for the vertical, basically turning that on its head and basically stretching that in the vertical, stretching upwards. That's where the lift comes into play, because we're starting to lift that column of spinning air farther up into the sky, into the vertical. So whereas the shelf cloud is going to slope away from our precipitation, precipitation's over here, it's going to slope away from the precipitation. That's going to indicate downdraft or outflow, storm breathing out. Kind of think of the storm breathing out. The wall cloud is going to slope towards the precipitation. It's going to indicate updraft or inflow, the storm breathing in, taking air in, and that's going to produce this funnel that you see. And again, that's going to be taking in the outflow, taking in the wind, taking in the air, pushing that into the storm itself. Now, the funnel cloud is the rotating funnel-shaped cloud extending downward from the thunderstorm base. It's going to be, again, always attached to the cloud base, but does not reach the ground. By definition, it's not doing any damage on the ground. And you can look at the ground here. There's no damage being done. You can't see any tornado damage being done. You can't see any debris, nothing that would tell you there's something going on the ground. But you can see a laminar or striated look to this cloud. That basically just means wind smooth. So the wind is making it a really smooth looking cloud because there is wind going around it, and that's producing that smooth look to the cloud, like you're sanding it down, so to speak. You're kind of producing that look to it where it's really, really smooth. Now the tornado is all of those things: rapidly rotating column of air with the cloud base and the ground, but also showing damage on the ground. You can see on the bottom here, there is damage being done on the ground. There's debris getting kicked up. Now that could be dirt, that could be, home or property debris of some sort, trees. It's going to be something that's getting disturbed on the ground, something. Now you can see the one in the middle here, there's actually two tornadoes. So that, without the condensation funnel, you don't need the condensation funnel to see that there's a tornado there. There's damage being done there. So that damage is your proof that there's a tornado going on at that point. So from a spotting perspective, you're looking for that smooth funnel appearance because it implies rotation. So it's likely going to be a funnel cloud or a tornado. Now, you might have run into some tornadoes that are kind of skinny looking or roped out or something like this. That's as much of a tornado as anything else. It might be a little bit weaker or a little bit of a different makeup atmospherically, but it's also a tornado just as much as this one is. So again, they're going to come in different shapes and sizes or flavors, but they're all going to be tornadoes. Now, in terms of appearance, some are going to be kind of ragged looking or, kind of, rough looking in terms of, not being the most picturesque tornadoes in the world. Nonetheless, it's doing damage. So it's a tornado. So certainly always be on the lookout for that vertical motion and rotation. And that's going to be what your hallmark for what's actually going on. Now, this is important as well. If it's not showing rotation or upward motion, it's not a funnel cloud or a tornado. So you look at something like this, and that might indeed look quite menacing. But the first thing we would say if you were to call us and ask us about this is, do we see rotation? We would ask, do you see rotation? And as you watch this, what do you think the answer would be? Probably not, right? So there's not really a whole lot of what I would be able to key into as rotation at play here. So we would say to keep an eye on it, keep watching it. But in situations like this, there's really not much to say other than keep monitoring it. If it starts to rotate, let us know. But really, unless it's starting to do damage or anything of that nature, this is what we call scud, S-C-U-D, scud. You can also call it scary looking clouds if you'd like. What it basically is convective debris. It's basically when thunderstorms develop, they leave some clouds behind. They leave some behind, just convective debris. And this is just clouds left over from thunderstorm development. So these are just leftover clouds. So they're not really doing anything. So we would say keep watching it, keep an eye on it. If they start to rotate, by all means report it. But in this instance, this is what we call scud. On the other extreme, you might be watching something like this and kind of not really, too concerned about it. That very, very quickly can escalate and turn into something like this. This is not accelerated. This just happened. And again, very, very rapid rotations in shape or what's actually going on can occur. And you get something like this where it can very quickly turn into a tornado. Which brings us to squall lines. Squall lines, like we talked about in part one, we can get tornadoes on those in terms of tornadoes can form on the lines of thunderstorms themselves due to the amount of shear that's present. They'll typically be weak, typically EF0, EF1. In rare cases, they can get up to EF2, EF3. The problem with squall line tornadoes is they're typically going to be what's called rain-wrapped. And what rain-wrapped tornadoes do, because they're so dangerous, they're going to be virtually impossible to spot. So you'll just see a line of storms coming upon you, and by the time the storms have started to move into your location, once you get past the heavy rainfall, you'll then see the tornado. So the amount of time to get to a place of safety is going to be that much smaller. The time is going to be that much smaller. So when we say to trust that warning that's out there, even if you can't visually see what's going on, trust that warning that's out there because the radar is telling us, or maybe somebody in a community away from you is telling us, hey, there's a tornado here. You might want to be aware of that. And that's going to be something that, we might only have a minute or two to report that. It might develop, it might come down and go right back up into the cloud. And it could be very, very, very quick in terms of how long it's on the ground and what kind of damage it does. But squall line tornadoes can be very, very tricky because of that. This is a rain-wrapped tornado on the Chesapeake Bay, and you'll be just watching this thunderstorm, and it really doesn't look like much initially. But as you look more and more into it, there is a tornado in there. It's what we call a water spout because it's on the water. But certainly there is a tornado in there. And that, again, after a couple of minutes of watching it, you do see the tornado, but it takes some time, which is the danger with the rain-wrapped tornado. Which brings us to uncertainties when you're spotting, when you're not quite sure what it is you're seeing. We say, go ahead and report it anyway. Give us what you do know and let us take it from there. Report what you see, give specific detail. Instead of making an assumption, saying I see a funnel cloud, say, hey, I see a possible funnel cloud because it's attached to the storm base. It's lasted for the past few minutes. It's a bit far away from me to see movement or rotation. Maybe it's beneath the tree lines. You know, we live here too, and we know the tree lines are very frustrating in terms of spotting. It can be very difficult to figure out what it is you're exactly looking at. So by all means, we know you don't have all the answers all the time. So let us know what it is you do see, what it is you do know, and let us take it from there. I'd rather have a partial report than no report at all. So let us know what it is you're seeing in your location, and we will take it from there. People think of our operations area and they think we have used lots and lots of resources and full use of a big mission control type facility. And yeah, that's not us. We don't have something like this. This is mission control down in Houston. I wish we had this much space, but we don't. This is us. This is us. We have a couple of computers, a few meteorologists working at a time. We can have 2 to 4 meteorologists at a time working severe weather events. We can get up to 8 to 10 during severe weather if it's really, really bad. But we will only have a couple of folks answering the phones. So time may be of the essence. We might not have a whole lot of time to shoot the bull with you or talk and get information from you. So please don't be offended if we're taking your information and moving on to the next person. It's not that we don't want to talk to you. It's just we are processing a lot of information in a lot of cases. So keep that in mind. And please don't let that dissuade you from calling, because we do want to hear from our spotters very much. We have had questions. Do we do local tours? And yes, we do. If you go to our webpage at weather.gov/Wakefield, just look at the local programs tab and check out the tours section from there. You can request a tour, and we will do our best to honor that request. By all means, check out our YouTube channel as well. We've got a virtual tour available as well. So bringing us to reporting to us. So start with the basic information. Let us know who you are. We're not going to give spotter IDs anymore, so we're not going to give you a code number or anything like that. But by all means, just identify yourself as a Weather Service trained spotter. Let us know your exact location, 5 miles west of wherever you are, near location, intersection of Road X and Road Y. Give us the most precise description of where it is you live. If you know latitude, longitude coordinates for where you live, that's awesome. I'm not going to yell at you if you don't know that information. So don't feel like you have to know it to report to us, please. And if you're observing a cloud feature or a tornado, try to figure out which direction you're looking. Most phones have compasses now, so be it the App Store or the Google Play Store or what have you, there's going to be a compass feature that's available. Try to use that as kind of a figure of which direction you're looking. For the exact time of the event, if it's ongoing or lengthy, provide a start and end time as much as is possible. For the event itself, all of this information is helpful. We're going to provide handouts once we get all of your information processed. We're going to send you all of our training handouts in due time. For those watching the recorded presentation, just send us your your information, and we'll get it to you. So the hail, thunderstorm damage, tornadoes, water spouts, flooding, all of this. Just report anything that you possibly can that fits these criteria. You don't really need to report lightning because we have lightning sensing information and lightning sensing information that comes in. But if you have lightning damage, by all means, let the county know about it, and they can certainly take your information from there as well. If you report something significant, please don't be put off if we ask for a way to get a hold of you, because we're going to want to follow up, most likely. See the couple questions come in. I promise I'll get to you at the end here. In terms of hail size, please don't report marbles. Please. Not all marbles are alike in size. I don't know what kind of marbles they are in your world. Marbles might be a different size in your world than they are in mine. So just try to correlate it with something universal, like a coin size or a ball size, inches in diameter, things of that nature. Golf ball, tennis ball, baseball, quarter, half dollar, dime, penny, things of that nature, very easily recognizable. And report the largest hailstone size. If you've got a bunch of quarters and some half dollars, report the half dollars instead of a quarter. In terms of wind, realize that wind estimates are hard for everyone, meteorologists and non-meteorologists alike. It's difficult. It just is. So severe wind or power lines down equals damage. So if you have that, if you have some trees down in your neighborhood, if a power line came down, let us know about that, because that's important. That's damage. Measured wind speeds are going to provide the most accurate information. So if you have a weather station, that's awesome. Let us know what your weather station measured. Try to report the damage that you observe. This is a modified Beaufort scale here. So report kind of based upon this scale here. That's the best way to kind of guesstimate what kind of wind speed you're looking at. Once again, if you see damage, report the damage, because that's going to be the easiest thing to report. Try to make it as simple on yourself as possible. Once you get into severe criteria, these things that are shaded are going to be the most timely. Shingles getting blown off, large tree damage, perhaps some light structural damage, things of that nature. And again, time of the event, location, speed, those are the types of information we're looking for. You might want to take a picture of this shot here. This is how you get a hold of us. That number there, that 757-899-2415, that will be answered by a person, an actual person, 24 hours a day, 7 days a week, 24/7, 365. We will always be here. The caveat there is this is severe weather reports only. So if you have a forecast question, go ahead and use the 4200 number, 899-4200. You can use that during business hours. If you call that number and ask forecast information, we're probably going to politely ask you to call back at that time, because we need to keep that number open for severe weather reports. For our amateur radio folks, our amateur radio community is very, very much appreciated for all the work that they do. So relaying information to us. So go through Net Control. You can send those reports to us, and they will get a hold of us via our email and via our contacts. So by all means, use your circles to talk with your Net Control person, and they will get in touch with us in turn. As I said, social media is a great way to get a hold of us, Facebook and Twitter. Typically use the phone or use our social media feeds for direct reports if you have something timely, because we might not be able to report on things like that via email in a timely way. If you are taking pictures, use social media, use that email. Feel free to send us pictures of damage that you have, or cloud features that you see, or cool things that you're looking at weather-wise out in the community. In terms of cold calling, we don't do much of that. So don't feel like you're going to be just put on the spot by us very often. We're not going to know where you are. We don't know if you're paying attention to the weather very much. We don't want to presume that you're following the weather if you're not calling us. So realize that we do want to hear from you, and our issuing warnings does take precedence. So we're not going to call and bother you unless you're trying to get a hold of us. And try to know your exact location with proximity to the storm as much as possible. Again, help us to save lives as much as you possibly can. Again, one more plug for our amateur radio folks. They do a great job for us. WX4AKQ.org, your one-stop shop for all things amateur radio. Net control frequencies, contact points. These folks do a great job, and we really appreciate them for all the work that they do. By all means, send us your reports via social media and email. Be sure to identify yourself as a spotter. That does give us a little extra knowledge that you know a little bit of information about the forecast and what goes into putting in a severe weather report, and that's very helpful for us. In terms of safety, this is the disclaimer portion of the show. Your safety is of utmost importance. There's not a magic bubble to protect you. Make yourself as impervious to the storm as possible. Try to know where the storm is, how close you are to it, how far other storms are from you. Are you safe from lightning? Are you in a safe place for hail or flooding? Do you have an escape route? Do you have a place of shelter? Realize that storms can very frequently change directions, so we don't encourage you to try to outrun storms in a vehicle. And visibility is often degraded around our thunderstorms. A little bit about lightning safety here. Just that quick can turn into a lightning scenario. Brief review. How should this be reported? The answer in this case is D. We don't want you to get too far into the weeds with reporting tornado versus straight line versus anything like that. Just let us know what you're seeing. A few trees getting snapped by the wind is what you're seeing here. Just report the kind of damage that you're observing. In terms of the lightning, you want to be indoors as much as possible. If you're close enough to be struck, to hear that thunder, you're close enough to be struck by the lightning. A little bit for CoCoRaHS here. For anybody that does wind report or does rainfall reports, you can report directly to CoCoRaHS on a daily basis, and they will host your rain reports online for free. And they will automatically forward those rain reports on to us. So you don't actually even have to do that directly. They'll just send it directly to us, which is really, really helpful to kind of fill in the gaps weather-wise between different points in our area. We can use that rainfall data to improve accuracy in warning events and for research purposes after the fact. So CoCoRaHS is a really great way to report rainfall if you are interested in doing so. So CoCoRaHS.org is the web address for that. The Mping app is a great way to kind of report what it is you're seeing out in the community, so you can report anonymously. Real-time weather reports from your location on any mobile device. It's on App Store and Play, and it's able to be viewed on the website there, mping.nssl.noaa.gov. You can go ahead and view in real time what other folks are reporting on their applications for Mping. And you can see what other folks are reporting in real time, which is kind of neat. Now, the basis for this class is the Spotter Field Guide. And basically, the Wakefield Spotter Field Guide contains the summary of everything in this course. And it's available for download on our website at weather.gov/AKQ/Skywarn. We're going to send a copy along via email as well. Really easy to download this onto your smartphone and just have it for your leisure. Once again, this is the basis for this entire class. So you can just read this Spotter Field Guide, and it'll have all the information that you need to report in real time. For those looking for a spotter certificate, just go to our webpage, put in your first and last name, click the date for today's class. If you're watching the recorded version, just click the online modules button, and you can just click submit, and you will get an online spotter certificate that you can watch or that you can save for your purposes. If you need to identify yourself for cert purposes or for purposes for later on after the fact, you can use the spotter certificate in that realm for that purpose. Once again, your information is not going to be going anywhere. We are basically just using this to get a catalog of our spotters that are existing out in the field. It's not going to go anywhere. We will see where our spotters are, but to identify for future classes and where we can go for future classes. But we're really not distributing it anywhere, so it's not going to go anywhere. In terms of a spotter card, if you want a spotter card, just go to our webpage at weather.gov/Wakefield/Skywarn, click the spotter card button, and you would put in 2024 Skywarn. 2023 will still work, but you can put in 2024 Skywarn. That is an uppercase S, otherwise no spaces. Just put in that password there, and make sure you click the printer-friendly version and follow the directions for your particular browser, and you can get a spotter card for your purposes. Once again, 2024 Skywarn is the password, and you can have a spotter ID card for your use. For spotter do's and don'ts, once again, brief yourself with the latest information. Don't assume we know what's going on in all places and areas, because we don't. We're doing the best we can with the information that we have. Please do understand the importance of your report, but don't put yourself in harm's way. Keep yourself safe, but don't withhold a report because of uncertainty. And lastly, express those uncertainties in your report, and please remember to pat yourself on the back. We appreciate you for being here and for paying attention to this course. We very much appreciate you having you here this afternoon, and we very much love having you part of our spotter network. So thank you all for participating. I will go through all of the questions I have in the queue here, so feel free to continue to add to those. For those watching on the recorded presentation, if you have any questions, feel free to email, and we will talk to you down the road. Thanks for participating today, and we will talk to you soon. All right, let's start looking at some of these questions here. Thank you, Ryan. Appreciate that. The information for the handouts will be coming from email. It'll be once I get all of these registrations sent down from GoTo, they will provide your information, and I'll be sending handouts at that time, probably within the next week or so. All right, a question here: what makes our hurricane seasons bad versus a season with little to no hurricanes? I also enjoy watching all the storm chasers. Do you think they help out? Well, Lynn, that a lot goes into play with the hurricane seasons. Certainly, there is the ENSO component to it, El Nino Southern Oscillation, the La Nina pattern versus the El Nino pattern. The upper pattern tends to be a little bit more favorable. Once we get into type of La Nina type setups, we tend to get a little bit more activity in those types of situations. Certainly once you get into La Ninas, they can be a little bit more of an active hurricane season. In fact, if you're looking at the hurricane forecasts, that does go into kind of the very high numbers that are being forecasted, is we are going into a La Nina type pattern versus the El Nino. And certainly, as you get into the latter half of the tropical season, September, October, that's really when the peak of our tropical season is. So a lot of that goes down to how long the El Nino phase can last and keep things kind of a lid on tropical development. But there are lots of other factors at play as well. But that's really kind of it in brief. We'll have some more information. It is actually Hurricane Safety Week this week, so we're going to have some tweets coming out on our social feeds this week, and we're going to have some more information coming out as well. And for anybody in the Norfolk area, we are going to be out at Norfolk for the hurricane tour this Wednesday. Another question here reporting. Before I get to that question, with respect to the chasers, certainly they don't put themselves in danger. Hopefully, they give us a lot of great information. So we very much appreciate the chasers giving us the information they have, but very much important that they are well trained and they don't put themselves in danger, because we don't want folks putting themselves in danger for us. Next question, reporting locations via lat long. Do you prefer DMS or decimal format? For myself personally, I can do it either way. Directly, decimal format would be most helpful. If you have a way of discriminating between the two, decimal format is more helpful because it saves me a step. But if you only can do DMS, I'm not gonna quibble with you too much. Glenn wanted to know what's an exciting advancement in severe weather forecasting we can see in the next few years. Certainly, Glenn, I think one of the biggest innovations is AI. AI is getting very much involved in hurricane forecast to some degree as well, but severe weather forecasting particularly in that it's learning very, very quickly how storms tend to follow a bit of a pattern, and they can be very, very helpful in determining what the severe weather mode is going to be, how widespread storms are going to be, and what the dangers are that they're going to present. So they are going to be, a very big part of our science going forward. The new radars, certainly, I wish we had some closer to our radar, which would be nice in our local area, but they're really, really nice to watch work. Yes, the question was, are we enjoying the new radars? Do they have better performance than the older ones? The modifications that are going on to our radar are really helpful to give us more clues as to what's going on in our thunderstorms. So there's that piece. They are a little bit more. They are a little bit more durable, which is part of the situation there. They are a little bit why they went down in the first place. They're a little bit more durable, so that is very, very helpful. There's also the terminal Doppler radars, which I think is another part of it, which other offices are able to use, which are basically FAA owned and controlled radars, but they are for very, very small areas. So they are a little bit different in terms of what they can do versus our radar, which has a larger area, which can kind of get to our entire area very well. Okay. That's all the questions I have now. I can hang out here for a minute or so if anybody else has any questions. Otherwise, we're going to go ahead and log off for the day. We'll get you our detailed information as we get your information into GoToMeeting here. So by all means, please don't be a stranger. We very much want to hear from you. Thank you for the kind words, Marshall. Everybody, have a great day. We look forward to hearing you part of our Skywarn network. Welcome to the team, and we will catch you on down the line. Thanks very much.